Here's what I believe that you know about functions. A function can be defined as a relation or as a mapping or even as a graph. But in every one of these cases, it has an input and an output. And in that sense, it makes the behavior of a function kind of like a black box or a magician's hat. If you put something in, you get something out. I could put in a bag of rice and pull out a rabbit. That would be a function. But it would only be a function if every time I put in a bag of rice, I pulled out a rabbit. If I took the magician's hat and I put in a bag of rice and I pulled out a ferret, I would take the position that the magician's hat had ceased to function. It wasn't working properly anymore. In order to be a function, every input must have a unique output. Another way to think about it is a drink machine. It's got a button for water. It's got another button for water. It's got a button for milk and a button for milk. And it's got a place to put in your money. You put in your money, you press a button, and something comes out. As long as when you press the water button, water comes out, and when you press the milk button, milk comes out, that's okay. That's a functioning machine. That's a function. The input is the money and the pushing. For this choice, you get water. For this choice, you get water. For this choice, you get milk. For this choice, you get milk. The fact that there are two water buttons doesn't mean it's not a function. But if you put in some money and you press the water button and you get milk, that's not a functioning machine anymore. That's not a function. So what does that mean? In terms of numbers, let's say I put in 1, I get 2. I put in 3, I get 4. I put in 7, I get 8. I put in 9, I get 11. I put in 15, I get 3. So far, is that a function? Yes. Sure it is. Every input has only one output. Is it a sequence? Is it some kind of a formula you could create for that? Is there a pattern there? No, but that doesn't make it not a function. Everybody okay with that so far? Okay, I'm going to keep going. Put in 27, I get 28. Put in 19, I get 8. Put in 17, I get 2. Is that still a function? Yes. It is still a function. For every input, there is still only one output. The fact that there are two ways to get a 2 doesn't make that less of a function. In the same way that there are two ways to get water out of this machine, there are two ways to get a 2 out of this function. I can put in a 1 or I can put in a 17. That's okay. Stop me when this is no longer a function. Right. What happened? I put in 19, I got a 6. The first time I got an 8. Something's wrong with this picture. This is a relation, and I could write it like this, or I could write it as ordered pairs. This would be, right, ordered pairs. This is a chart. This is what a map would look like. Let me just skip down a little bit so I'm not doing all of them. These are the inputs. These are the outputs, 2, 4, 8, 11, and according to the relation that I had before, 1 was mapped with 2, 3 was mapped with 4, 7 was mapped with 8, 9 was mapped with 11, 17 is mapped with 2, and 12 is mapped with 2. That's a function, a mapping representation of a function. The only way you could make this not be a function would be if I had two arrows coming out of the same input that were going into two different outputs. In terms of graphs, this is a function that relates every x value with a y value. For every x value, there is one and only one y value. So for each one of these, there is an ordered pair x comma y. It doesn't matter that over here I've got a second x value that would have the same y value. That doesn't make it not a function. The only thing that would make it not be a function anymore is if it doubled back on itself like that. Because then, for a given x value, you've got 1, 2, 3 different y values, and that ruins it, makes it not a function anymore. There is something called the vertical line test. I'm running a vertical line across here, and at any given moment, there is only one point on that curve that is on my vertical line until I get to here. The instant that there is a vertical line that I can draw that has 2 or more points on it that are also on the curve, it's not a function anymore. Let's take a look at a different function here. What if I had something that went like this and then like that? Is that a function? Keep in mind, this thing here means that it's an open circle, an open point. That point is not included. The point is included here. So for the value x is equal to 0, the y value is here, but not here. That means it's a function. There is no vertical line, even here. There is no vertical line that has 2 points of the curve on it, or of the graph. On the other hand, if I colored this in with red, I'm doing it with red so you can see that that makes it not a function anymore, but if I color this in with red, now it's not a function anymore.
So you just didn't put a point on there?
The first time I just had an open circle here to represent that there was no y value here at this point for this function, but there was one here.